Hi, Kevin.
Hey, good to be
Long,
back.
yeah, long time to see. So, what have you prepared for us today?
Yeah. I was last here for Prefect, and then I left Prefect last month, and now I've been working full time on Fugue, another open source project. So I will be giving a demo of Fugue and going over what Fugue does.
So, what does the name mean anything?
Yeah. So the main Fugue author, Han, is a musician. So Fugue is a music term.
What does it mean?
Um, it's just like I mean, I'm not a musician. I may be butchering this, but just like a composition with like multiple elements that blend together. Yeah,
And that's what you do, right? We will probably see that in the demo right now.
kind of. Yeah.
Okay, so let's see.
Okay, I'll share my screen here. So, and I'll make this bigger. So just to give an intro to the Fugue project, the Fugue project is basically wants to make distributed computing simple. So right now, if you have a lot of Python or Pandas code and you want to bring it to Spark or Dask, it's a bit challenging if you have to refactor everything in order to leverage distributed computing. So what Fugue wants to do is we want to provide this minimal interface where you can bring in your existing Python or Pandas or SQL code to Fugue, and then Fugue will be responsible for the execution on Spark or on Dask, Ray coming, right? And there are a couple of benefits to this. Number one is that when you test code, you're now testing on Python or Pandas compared to Spark or Dask. So you can test, your test cycles are a lot faster because these tools on the right-hand side require a lot of spin up time or are expensive. You have to use the cluster. So with Fugue, you can test here. And another thing is that you can also um, when you write your unit test or business logic, you can unit test this, and it's Fugue's responsibility to bring it over to Spark or Dask. So we'll see an example of that. So the example I'm going to be doing today is PyCaret. PyCaret is another open source project, low code machine learning project. And we'll first go over what PyCaret does
Can
without.
you enlarge the font a little bit now that
Yeah,
we need to look at the code? Maybe it's, yeah,
yeah.
thanks.
So PyCaret low code machine learning, we'll just go over a couple cells. They have this function to get data, and we'll get the Titanic data set. And then what PyCaret does is with a few lines of code, we're going to try maybe 10 plus machine learning models on this data set. So here on PyCaret, I'm just going to import PyCaret, and then they have these 3 lines set up, compare models based on accuracy, and then we pull the results. So this one may take some time to run. And what we're going to do is after we figure out like what PyCaret does, we'll work to actually execute this on Spark or on Dask. So this will take like 20 seconds. Because the imports also take a while. So this will be faster later.
And you will tell us later what exactly is happening, right?
Yeah. So this is the what PyCaret did. Again, no Fugue. PyCaret just trains all of these models off the shelf, and you get all of your accuracy metrics. So you can test a lot of models with very few lines of code. So what we want to do is we want to bring this on to Fugue to run on Spark, and we want to. I'll show later what the goal is. But first, in order to bring it to Spark, what we need to do on the Fugue side is we need to provide this wrapper, and this wrapper is just a function, and this function will let us port it. This code is all the same. The formatting is just slightly different, but it's the same as this. And then instead, at the end, instead of returning all of these columns, I'm only interested in some of them. So I'm making a new data frame to return. And then I can call this now with this transform function from Fugue. And I know you can just do wrapper df right now, and this is perfectly fine, but we'll see how the transform can later bring it to Spark also. So the transform function is Fugue's most minimal interface, and it provides like an engine agnostic representation. So later we can say transform on Spark, transform on Dask, or in this case, when I say no transform, I'm just no engine. I'm just going to run it on the pandas engine. So this is the same thing. Nothing special going on with transform. Schema is a requirement for distributed settings. So if you work with Spark or Dask, you need to supply an explicit schema. So on the Fugue level, we need to require it in order to be able to bring stuff to Spark later. So let's talk about the first feature of transform, and that's partitioning. So let's take a look at our Titanic data set. We have some records that are male and some records that are female, and we've been training models for the whole population. What if we want to train one model set for the male and one model set for the female? So we want to group by and then train. On Fugue, we just have to make minimal changes. So here's the wrapper, and all of this will stay the same. I just need to return the group key also, so I know what the group that was trained. So here I'm going to say sex is equal to df iloc 0 sex. And this means that now this function, I'm preparing it to handle one specific sex, either male or female. But when the data comes in here, it will either be male or female already. And I'm going to run this. And on the Fugue side, but we're going to return the schema, the sex as the schema. And over here, all I need to do is say partition by and then sex. And now when I run this, again, this is still testing on pandas. We haven't brought it to Spark yet. We're going to see that there are some models being trained for male and some for female just by adding this partition, right? So we have sex female, bridge classifier, male, SVM. So now we're ready to bring this to Spark. Now, all I have to do is, this is the same. So I'll make a Spark session first. I'm already connected to a Databricks cluster. This Databricks cluster is already on. So when we run Spark commands using Databricks Connect, it's going to run on this cluster. So we start our Spark session. We're connected now. And now all I have to do is, because this is connected to the cluster already, this is the same transform call. All I have to do is say engine equals Spark. And this Spark is the Spark session. So again, schema is a requirement. This one is, I just have to replace the null values with none because NumPy NaN doesn't play well with Spark. So I have to replace them with none to bring this to a Spark data frame. And then this save path will save the results like this at this location. So here, this will now run on the cluster using Spark. And it will save the results here, and then we'll load it for some post-processing later. But you can see that that'll take a bit. So we iterated just by using the transform function. First, we just ran everything. Second, we partitioned. And then now when we're ready to bring it to Spark, all we have to do is specify an engine, and then everything will run on Spark. Similarly, you can also run on Dask using the following syntax. You can do this. And if you don't have a Dask cluster, this will get the Dask client that already exists, or you can also pass the client here itself. If you don't have a client set up, then this will run on local Dask. Similarly, if you don't have a Spark cluster, this will run on local Spark. So we have this already completed.
Just,
and we
curious about this Spark thing. So you pass it to DataFrame. So what you do internally is you turn it into a distributed DataFrame to Spark DataFrame, right? And then you send it to Spark. And then, like, what happens next? Like, you train a model there? Is like you do some sort of MapPartition, or what exactly?
Exactly. So I mean, when we talk about Spark, two things. Number one, this can either be a pandas data frame or Spark data frame, and then we will convert it based on the engine. Number two is that actually this transform, if you, for example, we were testing on local data on like some file like temp/sample.parquet, Fugue will load this in. We'll load in this file using this engine. So it'll say Spark read parquet and then this file. And then when you're ready, you can just say full data, right? And then you can run your whole pipeline. So that's the first one. You can use file, you can use DataFrame. If DataFrame is converted, if you're interacting with a remote cluster, it's more likely you're going to be using the file path instead of this like DataFrame, because the DataFrame will be transferred. It's just easier to demo the DataFrame because we can view it locally and I can show you what it looks like rather than this Parquet. The second part of your question was, do we use MapPartition? So
Like group by and then you apply some function, or
exactly,
what's going on?
So with Spark, there are many ways you can bring existing code to Spark, right? You have map partitions, map in pandas, apply in pandas, UDF, pandas UDF, right? And it depends what arguments you supply, and then we'll use the appropriate one, right? So here we supplied a partition, so that can be map partition. Maybe you don't supply map partition, so we'll just use UDF, right? So our point is you shouldn't have to learn all the interfaces. Fugue will handle that for you. You just need to learn this transform function, and we provide a simpler, minimal interface. For anyone who's worked with Spark, you know that the Spark schema, I've heard of a lot of engineers writing code to work with the Spark schema. Like they have like functions to kind of build that schema for them. On the
It's
Fugue
like
side,
every second one, right?
what do you mean?
Like every other person who needs to write with Spark ends up implementing some code for
Yeah,
that.
because the Spark schema is very tedious to deal with. You have a lot of like classes. So Fugue does that for you under the hood also with this very minimal representation. And then we will be the ones to handle the schema operations also. But
I'm
that's
just curious,
yeah.
maybe if it's something that is easy for you to show, can you show the plan, execution plan for this job in Spark?
I think maybe I could on the Spark UI side. I don't know. Like this is I mean so here you kind of get a hint of it, but not really. You just see this wrapper, which is our function that was called, and it's just being applied in a lot of jobs. I think this is the best I could do there.
Okay, but
Yeah.
I see that there is one stage. Something.
Yeah. Do you know how to get the plan? But
No,
this,
usually like it's just clickable and then you click, but I never worked with Databricks, so I don't know how it
oh, I
works.
see, I see. But this
Oh,
this
never mind.
this does push down to Spark. So
Mm.
we are using just native Spark under, right? Ignore these scikit-learn warnings. There's just like some like deprecation warnings that I tried to filter out, but it's not. So we saved something already, and the next part is FugueSQL. So transform is the most like minimalistic Python interface. FugueSQL is built on top of that Python interface. So we can have a SQL command. So here we load is a keyword we added and print is a keyword that we added. So we can load this from Parquet and print the head of the data frame. And then we can FugueSQL, if you don't specify an engine, it will run on pandas. If you specify Dask, it'll run on Dask. And then here we're running it on Spark. So this goes to Databricks also, loads the Parquet that we generated earlier. FugueSQL also supports standard SQL. So here I'm saying load the results, and then we have this time column, and I'm gonna say what's the total training time for female and total training time for male. So now we can group by sex, get the average time, and we get our results. Now I want to collect the top 5 models for male and top 5 for female. So what I'm going to do is load my results and then take 5 rows from the data frame, pre-partition by sex, pre-sort AUC descending. So I'm getting my top 5 models, and then I'm yielding this local data frame. So this is like a 2 pandas operation. And by doing that, I now have a local pandas data frame where I can view my results. So this is now running on local pandas. And then for the last part of this demo, what I'm going to do is show how, so Fugue added some keywords like take, pre-partition to extend the SQL. We also added some kind of syntax syntax sugar, like you can use this df equals something. So you can also say, for example, df equals select star from, or df2 here from df, and this will work. And then here you can say take 5 rows from df2, for example. So we added a bunch of keywords, and we enhanced the SQL language by adding stuff so that we can make it an end-to-end compute, like make it support end-to-end compute workflows. Because normally when you use Spark SQL, you have Spark code, and then you have Spark SQL code, and then you have Spark code again, right? So we want it to be the opposite, where SQL is a first-class citizen, first-class grammar, and you can just use SQL to express your workflow.
Okay.
So we
So
can have SQL invoking Python code. Yep.
Interesting. So because I know, like for Spark, you have Spark SQL, right? But for Python, I guess you needed to implement all this yourself. So you needed to first, like, I don't know, come up with a logical plan and then assign each operation to each of the steps in the plan, right? So you basically needed to build your own SQL engine.
Exactly. So it's not that we build our own SQL engine. It's more like we build a SQL parser,
Yeah.
and then the parser maps to the appropriate engine commands. So for Spark, we have Spark SQL, but yes, Pandas doesn't have, well, Pandas has Pandas SQL, but that's not,
does it?
yeah, there is, but Pandas SQL just pushes everything to SQLite and then kind of just like uses that back and forth. So it's not
That's cheating.
necessarily efficient. Yeah. So we get the SQL, we map it to Python code and push down to Python, to Pandas. But then realistically, locally, there is, I don't know if you're familiar with DuckDB, but DuckDB is a very, it's like a SQLite, but it's OLAP instead. So it's optimized for analytics workloads. DuckDB will be more efficient, and it has lazy evaluation as well. So in a lot of cases, like you'll be testing, like here for this one, for example, we could be testing on DuckDB. And then when we're ready to bring it to Spark, we can say, run this on Spark. We have pandas too, but pandas will tend to be slower than DuckDB. So I have this pandas data frame now. And what we want to do is invoke Python code inside SQL. So we have this plotter function. All this does is make a seaborn plot. And now we have a pandas data frame called result. This is running on the pandas engine. And I'm getting all the male items in my data frame and output using plotter. And this is a graph of recall here and precision here. And we have, oops, I can't make this text bigger. The model names attached to the points. So FugueSQL also supports, here we have a function where we just plot something, there's no return, but we also have keywords like transform to, if you want to support like custom transformation, and you can say transform df using some function. And we also have this syntax. And with that, that's the end of my presentation. Just want to wrap up here that Fugue aims to make distributed computing a lot easier. We want to allow you to be that bridge between local execution and distributed execution. And we want you to be able to keep your code in the grammar that you prefer, or the grammar that's easier to express what you want to do. And then, because we find that Spark introduces a lot of boilerplate, Spark has a lot of times when you couple together logic and execution in the same code, and we want to decouple that. So you purely focus on logic, and then we worry about the execution later. And Fugue is the execution piece where we take your existing logic and we bring it to Spark or Dask for you. And I'll stop sharing my screen.
How many people work on this? Is it just Han and you, or?
Predominantly, and then we have some other contributors here and there that, you know, pop in. Yeah.
If somebody wants to hop in and help you, how do they do this?
Oh, definitely feel free to reach out. Oh, I guess I didn't show the GitHub. I'll just show the GitHub real quick. And then we have a Slack. So this is our GitHub, Fugue project/Fugue. And we have, you can always join our Slack, chat with us. We're always happy to chat about any like distributed computing or Spark or Dask or anything. If you're just in general like struggling with like, my pipeline on pandas is taking 2 hours, just chat with us and we can figure out how to bring it to distributed computing for you. So just feel free to join the Slack channel.
How to give you a star?
Start. You already
Yeah.
started the repo. I know, but if anyone wants to, if anyone is kind enough to give us a star, please just click the star button. We really appreciate it.
How do you know?
How do I know? I actually check every day who the stars are, and I email
Ah,
them and I'm like, hey, thanks for starting the project. Let me know if you need any help, right? So I check all the time who the stars are.
so what are your plans? What do you want to work on?
Yeah, so really right now it's just like there's a lot of work to do with Fugue. Like for example, something interesting. Number one, Ray is in progress, right? Number two, something interesting is Snowflake, right? Released Snowpark. And if you talk about like Python invoking SQL or SQL plus Python together, it fits our paradigm really well. So maybe something that we could do is build a Snowflake backend. And then now you're testing on pandas, and then when you're ready, run on production Snowflake, right? Because like Snowflake is like, it's hard to test. You need a test instance. But now with this model, you can just test on your local on pandas data frames.
Actually, I haven't heard about this. I heard that Snowflake was going to introduce Python, but
They are Snowpark. It's been released,
yeah,
yeah, officially.
yeah. Do you have any advice for anyone who is watching this?
Yeah, I mean, our not necessarily advice, but just to speak about our philosophy. Our philosophy is that the code should be decoupled from any framework. Like you should not have these massive dependencies. If you use the Spark interface, you are locked into Spark. We use the Spark engine today. I didn't show any Spark code, right? And even like Fugue itself is very minimal. If you want to remove Fugue, just remove the transform function and just call the function yourself. So we aim to be very minimal and very replaceable by the user also. We want to adjust to the user, not have the user adjust their code to fit the framework, right? Because data scientists, um, we data scientists, their specialty is analyzing the data, having that domain expertise, and a lot of times they have to grapple with like these other tooling that is not necessarily their specialty, and we want to remove that friction for them so that they can really focus on that business logic piece.
Just wondering. So you mentioned data scientists, and I guess they are your target audience. And let's say I, as a data scientist, already have a bunch of pandas code that is doing some weird logic. How easy would it be to start using to migrate from this to Fugue?
Yeah, but using Fugue trivial, right? It just transform, and then we'll apply that per partition. If you had to bring it to Spark yourself, there's like you need maybe 2 or 3 helper functions in
Mhm.
order to get it in the form for like map in pandas or something, right? So we do that under the hood for you. And then like it's kind of like what we find is that by following best practices, so let's say you have a pandas function already, and then you need to bring it to Spark. You have to create those 2 to 3 helper functions, and then you have to unit test those 2 to 3 helper functions. So you're actually penalized for following best practices, and you have a lot of more work. But with Fugue, because you just use transform, you're testing your original logic. Transform is our job to test as an open source library, so you don't have to write those additional tests. So it should be very trivial with Fugue.
What's your test coverage?
One, I think we're 100% right now still for
Yeah.
Fugue, for the Fugue project.
Awesome. Awesome.
Yeah.
Okay. Well, I guess that's it. Thanks a lot for joining us again, for showing the demo, and have fun building Fugue.
All right. Thank you. Thank you so much for having me.